Okay, so my name is Brian Bartholomew, and I've been around UF and Gainesville for a long time, and I've been doing sysadmin for a long time. And this is my current state-of-the-art. The product is called Host Factory. It's a GPL2, and you can download it. And I'm going to present 3 case studies tonight. So what is this thing? Everyone's heard of rsync, I assume. Some of you have heard of rdist, perhaps. That was the earlier version of an incremental file copier. This is the idea that you do system administration by monitoring every file on your remote system. And if it's wrong, put it back. And if it's changed, fix it. I originally presented this at Gatorlug in October 2014. And there's about 50 slides there. Okay, 18 public versions released. I don't think there's anyone else in the world that are using this besides me. It is up on the web, but the release process lets my software update works on my other laptops that I don't have source code on. So there are 18 releases still in development. All right, so my 3 case studies are, the first case study is the 2 Raspberry Pis sitting in front of you. It'll be live. We're going to put some files that shouldn't be on there, which we'll pretend is malware, and we're going to find it, and then we're going to remove it. The second case study is my Linode that's sitting underneath my website, and that's up in Atlanta. And been managing that now for 2.5 years, something like that, using this system. Basically, anywhere that I ever used rsync, I'm now using my own stuff, my own backups. I love it. And the third case study is I have an application customer. They have a system that's 3,000 miles away, and I needed to extract a subset of that for a test machine. So we'll talk about that. Okay, so stuff in the typewriter font is stuff that's going to be running. So I'm going to get that started. And yes. Okay. All right. Okay, so while this thing runs, it'll take about 3, 4, or 5 minutes to run. I'll show you what these windows are. This window at the top is tailing the log files from it running on 2 different machines named Pinnis and Pierogi, and you see the file names go by. This window at the bottom is running the 2 programs in parallel. So it's just going to wait till it finishes. And functionally, there are several pieces there. So what we're actually running now, does that work? Can you see the dot from out there? Okay. So here are my 2 test machines. Here's the disk part that's running. And here's the stuff that came behind it. So I am generating on the fly an image of what those 2 machines should look like, with exceptions for files that are supposed to vary between the machines. So the various disk tools have always had exceptions by file name, but they didn't have exceptions for owners, which should vary, sizes, which should vary, modification times, which should vary, stuff like that. So you can never quite get the coverage that you wanted. And that really is the functional difference for this tool versus other ones. And let me show you the other window. Okay, so here is the earlier process where I take the MySQL database, which has a list of hosts and usernames and printer names and room numbers and all that other stuff you want to keep track about your site. And it generates all the flat files that belong on the machine. So on this window, that's that going by. So on these 2 pies, there's not very much, so it goes pretty fast. I have another sample which generates web output and tables and maps and charts and all sorts of good stuff. But once you've got it in the real database, you can do anything you want with MySQL. Okay, so this is going to finish real soon now. Any questions so far? Has anyone found? Yes.
What underlying technology did you build this on top of?
Okay, it's SSH, so it's not sitting on its own daemon. All the programs here are either Perl 5 or Bash, and there's an enormous makefile. The man pages are in Pod, which generate all the different formats. The documentation is in LaTeX, which generates a bunch of different formats. The database is MySQL. This thing started off in Perl 4 back in the 90s, but when I first got packages in Perl, it got a lot easier to deal with. But it's architecture independent. There's no binaries, so I don't actually change between the different architectures. So I mean, basically, it's distributed like shell scripts. There is a hook for apt-get that you can install it that way. That's how I do my own updates.
Hey, Brian?
Yes.
You're doing the file integrity checking?
Yes.
Is it doing like byte comparison checksum? What's it do?
There's 2 switches. This is the faster version that's only looking at modification times. There's another switch that will compute checksums. So because of does a modification time really mean the file changed kind of thing, we'll see in the later example where what I will really do if I'm curious is I run the first one with checksums and figure out what's going on, and I'll talk about that a little bit later, and then go back and run the modification times once I get a handle on it. So from a am I being fooled standpoint, you can't run the file. You can't really believe the files that you're checking if you're doing this on malware, if there's malware installed. So you would need to mount those disks, somehow access them some other way. But
I catch a script kiddie, but a serious hacker would be better.
yes. But the path names are sufficiently flexible that you see there's no slash at the beginning here, so that those things that it can be checking can be anywhere, and it's, you know, one line for changing the top level kind of thing. So it's really intended for all that kind of utility stuff. Did I answer both the questions? Okay. It only took 4 minutes the last time. Okay, so what else do I like to talk about? Go back to that. The one labeled bulk in the Raspberry Pi case is about 3 gigabytes of distribution that has been checked into Mercurial, including all the owners and the modification times and the devices and all that other stuff that Mercurial doesn't do. There's another shim layer that keeps track of all of that. So I actually have version control on my base distribution stuff. And to make a small modification to that takes about 40 seconds to run, check all 3 gigabytes and put it in. And I think I was set to show that yeah. So this is my directory. Looks like a Linux top level directory, but it's actually in Mercurial and dev and everything else. Okay, so finally finished. Alrighty, so I get some results, and so I'll go look at the log files. Okay, no differences, that's what I would expect. Show some time. So it saw 3 gigabytes on the machine, and this time it took 7 minutes, and it doesn't want any modifications, which is what I said. There's a distribution of files, directories, symlinks, some counts, some times. And that was for the first machine, and this is for the second machine. Same log file, same results. Okay, so now we're going to go break the machine. Okay. Okay, put some bad stuff at the end of the shadow file. Obviously not real malware, but you get the point. So to make the demo faster, rather than scanning the entire machine, I'm going to limit the scan to only the etc. directory. So instead of, in this case, 7 minutes, and that's the -L, etc. here, and that's really just for the demo. Okay. So it found it. See on the log lines for the people, one machine which wasn't touched is clean. This one, wrong modification time on shadow, and the file's the wrong size. And all of that stuff is, I want to do the pierogi one. This is the log file version, which says the same thing. And there's also a an rsync format version of the same. So, okay, so I have files that I don't understand, and I don't like that, and it's on. Okay, so I found I have files that I don't like, but that machine's over there, and that, it could be somewhere far away. So I want to pull anything that would want to update. I want to bring those copies back and stick them somewhere else so I can go examine them. So it's running through the same, it's not examine, making it, yes, that's supposed to be. All right, and then we get a new line which says, here are the files that I copied back, and to show you that they really are there. So there's the stuff that shouldn't be there. So I ran this in parallel. I can pull back all of these changes and sift through them over time, figure out what's going on. Okay. So I'm going to fix it. And here's the fix. You may wonder what the coverage is. Obviously, I can't check everything on the remote machine. For instance, I don't check the contents of temp because I can't predict that. But there's a very small list of what is not covered. I don't want to show config files. We'll come back to that. All right. Any questions on that example? Anyone have a big collection of Raspberry Pis that they would like managed? No big Pi users. Okay. So performance numbers. Yes, that's a new one. So 3.5 minutes, that was actually real. It was 7 here. 7 seconds to do the etc. 35 or 40 seconds to check in something into the version control. And this laptop was fast when I bought it, but it's now probably about 3 years old. Okay. Next one. My Linode in Atlanta. I'm going to scoot over. Like I said, I've been managing this for about 2 years, 2.5 years with this software. Never found any malware or anything I didn't expect. Has anyone found any malware on Linux? All right.
I guess I'm good then, huh?
Okay. Well, but they didn't get in that you know of. Okay. All right.
You get port 22 open on the internet.
Yes.
You get a lot.
Yes. Yes. About 50,000 a week. I've
You can
noticed.
fill your Raspberry log up very quickly.
I bet it can.
We can move it forward.
Yes. So this is my system in Atlanta. There's 9 gig. I ran this one with the checksum on because I did this on Monday. Hadn't done it in a while. So I ran it with the checksums on to see what was going on. And it said it wants to update 250 megabytes. Most of that is because I haven't turned the automatic update for apt-get off. So those are files underneath apt-get. Those are not actually real changes. But there's a summary of creates, modifies, reloads, and deletes. When I did it at home, outside of Gainesville, it took 40 minutes with the checksums. When I've done it in Hackerspace, when we had better internet, I did it in 5 minutes. So I was pretty happy with that. This process was exactly the same as for the Pis. It's just different source files at the top. Okay, so what did I find? I found that here's a script that I use for rsync, wrap rsync. That changed. I hadn't propagated it to my machine. That was the path statement under a new version of host factory. So those weren't very surprising. Here's where I was messing with my mail. Now it only has the M time wrong. It didn't complain about the checksum wrong. So the contents that are running are correct, but the M time's not. And that's because I was fussing with it and then I put it back. But I didn't put it back completely. All right, so why is this header shadow modified? This is real. I didn't make it up for the demo. So that was kind of nervous. The checksums are the same between this copy of shadow and the backup. So whatever modified it the same both places. So I pulled that file back with the E-switch. I pulled everything back, and it sticks it off in a corner. And I compared it, and it turns out that when I put some mailing lists on, I had done it directly on the machine, and I hadn't updated my generators. So that was not a break-in. Sure looked like one. What else did I find? The Linode folks are updating my kernel, which they do that, so that's not broken. And some more changes that should be marked as correct in my generator scripts, but it seems like every time I go look, there's always more stuff that pops up. Run a machine for a day just doesn't seem to be enough to toggle everything. So those were actually correct, and I will at some point fix the generators to ignore those. So those sizes should change and the modification time should change, but it will still check the owner in the group and the permissions. And the way this worked is I did it one piece at a time. So the kernel changes were the last thing that I cleaned out because I wanted to make sure that I understood it. The script updates went quickly. I recognized the postfix and I just flattened that. The shadow is what had me nervous. Okay. And with the limit to check rather than the 40 minutes to go through the whole thing, it was like 60 seconds to go through a functional area. Okay, and there's the example of my clean check, same 9 gig, checksums off. How long did this one take? Can you read that? 35 minutes, I think it is. And it didn't ask for any modifications. So I know my machine is clean. I mean, somebody could break my programs are Perl, but it gives me something. Okay. So here's the third case study. Yes.
Why were you so blasé about Linode updating your kernel?
Because they do that. I don't have complete control of the machine. Their kernel has got their stuff in it for their virtualization.
And that doesn't scare you?
What do you mean? I mean, it's running in their virtual universe. I know that they have SSH access in some fashion because they shut it down cleanly and start it up and back it up. I mean, it's owned. It's in their box. Do you agree that I'm understanding what they can do?
I agree that you're understanding exactly. I agree that you understand exactly what they can do, and that doesn't worry you.
Well, I don't have, this doesn't have any of my PGP keys and it doesn't have any of my passwords and on and on and on. This is not my whole life. Yeah.
Another question.
Yep.
Do you think the 40 minutes is likely because of less bandwidth or higher latency or both?
That was on a DSL that's in Citra. So it's not, I don't think it's latency. I think it's low bandwidth because the protocol is such that it is pipelined and only does a turnaround every 50,000 files.
That was going to be my next question.
Yeah. Very pipelined. Very pipelined. Okay, so I've got a customer who I've written Perl programs for, and they have an Oracle database on a machine, and it's got a terabyte of data because they've been using it for 20 years. And I wanted a subset of that machine to stick in VirtualBox that I could use for testing. But the customer, who's also a knowledgeable sysadmin, has a lot of backup files and tar files and date name things. There's a lot of other things. So the exceptions that I don't want to copy down to my little bitty DSL are substantial. Machine's 2,700 miles away, and I have to get into the customer through a VPN, and the VPN runs on a VirtualBox on my laptop. So there's an additional bottleneck to reach it. And I'd like to do this only once. So when the customer does an operating system upgrade, I can pull down those things that they did and stick them in my VirtualBox. So how do I do that? So there's some details. Wake up. Have to get the SSH to go through the VPN. Copy files downloaded into a staging area. It took me, I think, 3 days to get them all down, and part of it in different places. But I just started up until I got them all. Loaded a VirtualBox with the same basic operating system as the customer used, which was, I think he's using Red Hat, so I had to get a Red Hat login. And after the download completed, I used more or less the same distribution exceptions to take my staging area and stick them on top of the base image that I had running in VirtualBox. And there are some details because that was a big machine and the kernel's different and it has RAID hardware and the multiple Ethernets and a bunch of stuff. So there's some fussing there, but it did actually work. And now I've got a 35 gigabyte VirtualBox image that's a good model for a terabyte machine. And the VirtualBox I can restart from a snapshot. So I run my code, it puts the wrong thing into the database, and I can just wipe it out and know that I'm not accumulating errors in the Oracle. Okay. Questions? Anybody have a big collection of machines? They'd like me to do this for them?
I had one question.
Yes.
Have you been following Google's publication about SHA-1 collisions? And you mentioned checksums in your tools.
Yes.
Like what checksum algorithm is it? And is it one of those that only reads the beginning of a file? And,
well, I hope it doesn't read only the beginning of the file. This is MD5 is implemented by Perl, probably.
So I think some of those algorithms only read like the first 512 bytes of a file and tell you whether they're and give you the checksum on that on some of them.
No. Reads,
but this
reads
is
the
a
whole
full
thing.
file.
Takes forever on the big
Okay.
files. Yeah.
And what do you make of that generally with a tool like this? Like with, if say your users of these systems are uploading documents that have collisions, like, and you
Well,
may not catch
the
it.
sales pitch for MD5 is that the output string is so big that you're not going to collide. I mean, the crypto people promise it, and then several years later they said, well, that's not entirely true. But if somebody's going to try to engineer a file to collide on MD5, I have bigger problems. So yes, this is really intended to catch errors and mistakes. Elsewhere in my work life, I worked in Boston. We had a financial trading floor, and there were 120 odd machines. And we eventually discovered that there were about 20 different versions of SunOS on those machines, which were all 4 point something. And we got our cloning tools, which at that time were hand carry around a SCSI disk. After we got our cloning tools fixed, we reloaded all of them, and a bunch of problems vanished because we were testing different versions of SunOS where nobody had ever tested that combination before. And we wiped it all out, and people were very happy because it worked.
How many downloads of HostVer?
None, as far as I know.
Nobody's downloaded.
Nobody's downloaded. I have tried to get a Linux Journal article written, and I have failed to convince my reviewers that this is different than Puppet and Chef. So that is my problem from a sales standpoint.
If you definitely don't care about people deliberately faking checksums, you could consider CRC, which is really fast, if the speed of MD5 is a problem.
Really fast means way faster than MD5?
Yeah.
Okay.
Did you, when you first started this, did you borrow ideas but not code from rsync and rdist?
Yeah, because I grew up from Randy, and that system was all rdist, and there were some other things, but mostly it was rdist rather than rsync. Yeah. At this point, The only thing I will use rsync in two situations. One is if I'm dealing with some other party, a customer or a vendor or somebody who I don't want to stick my software on. And the other thing is to copy VirtualBox image files around because the compression is 20x if I've only done. So the last time I copied that 35 gig thing, I did get a 20x speed up. But usually things are smaller than that. Nobody has any fleet of machines that they want to run this on.
This be helpful for somebody setting up a Beowulf cluster.
Oh yeah,
Those-
totally. The I think minimum machines is 50 to be worth the trouble. The example configurations are for download, and we can talk about that. So I think I'm on to number 4, number 5. For the Atlanta VirtualBox, the way I generated the master copy was I had 2 VirtualBoxes and the Atlanta VirtualBox, and I boiled down all 3 of them into the master copy. And there's quite a bit of stuff there, and a lot of modification times that are different that don't need to be different. So that's probably the next area that I'm going to work on, is basically generating distributions for, at least a demo, but for somebody that might want that.
I could imagine this being used as a layer on top of whatever they use at Hypergator. You might consider offering it to people who are big customers there.
Yes. I see Puppet and Chef as being the inputs into this model, because however you generate that, whatever higher level tools you have, just use them. No need to recreate those. Okay.